Alright, welcome again to this learning channel. My name is Adekoya Lawrence. There are about 11 important laws in Boolean Algebra that we shall be looking at today, and we call it laws of Boolean Algebra. The laws of Boolean algebra. I'll be giving us 11 important laws. The number one of such laws is what we call the commutative law. And what does the commutative law say? It says if you have an element A plus an element B, it is the same thing as saying the same element B plus the same element A. It simply tells us that the order of arrangement does not really matter when it comes to addition of two elements together. The same thing happens when you say A multiplied by B is the same thing as B multiplied by A, and that is what we call the commutative law. The order of arrangement, whether A comes first or B comes first, does not really change the outcome. The second one is the associative law, and this one states that we have three elements in an addition operation. A plus B plus C is the same thing as saying A plus B plus C. And this is simply telling us is that the order of operation does not really change the result. Whether you add B and C first and then add them to A, the same thing as adding A and B first and then adding them to C. So they are actually the same and no difference. The same thing when you have A multiplied by B multiplied by C is the same thing as saying A multiplied by B first, then multiplying them by C. We will achieve the same result. And that is associative law. The third one is the distributive law. And this is simply that if we have the two operations plus and multiplication in the same expression, to say A multiplied by B plus C, we can actually distribute this A over these two elements on the addition operation, and this will give us A multiplied by B plus A multiplied by C. And what this simply is doing, what we're simply doing here is that we are distributing this A over this expression in the parentheses, and then that's why we have A multiplied by B to have this, and then we have A multiplied by C to have this. And of course the operation here is what we are going to have between the two, and that is what we call the distributive law. The same thing applies to any element that find themselves in this kind of operation. The number 4 of this law, the fourth one, is the null elements. null element. So if we have A, for example, we have A as an element, and then we add it to 1, and then we achieve a what? A 1 as the result. We know that A is a null element. A is a null element. And so also if we have A, multiply it by 0, and then we have a 0, we know that this is what we call null element. So A dot 0 multiplied by 0, of course, you know, anything that is multiplied by 0 will always give us a 0. That is null element. Then we have the identity element, or the identity law. Number 5, identity. Identity. So, and this says that we could have an element A, so that when we add it to 0, it still gives us A. In the same way, we can multiply the same A by 1, and then it still gives us the same A. We call this the identity element. The identity element. Alright, so 6 of such laws more to go, and then we have let's assume we have the next law is called the idempotent. The idempotent law, and then it simply says, for example, you could have an element A plus A, and it is equal to A. Remember, this is Boolean algebra. This is Boolean algebra. So the idempotence law states that A plus A will give you A. An element added to itself will give you A, thus such that an element multiplied by itself, that is a multiplicative version, is going to give you A, also the same element. So the seventh law in Boolean algebra is called the complement law. The complement law, and it says when you have an element A added to the inverse of such element A bar, it is going to give you 1. It's going to give you 1. And when you have the same element A multiplied by its inverse, that is A bar, is going to give you 0. And this is known as the complement law. The next one is the involution law. Involution. Involution. And involution says that negating an element twice, A bar bar, is going to give you this element in its natural state. So that is involution. Next, number 9, I have the absorption. Absorption law, or the covering law. The covering law. So this simply states that if you have an element A plus A dot B is going to give you A. It means the element B has been absorbed. The element B has been absorbed. The same way you have A dot A plus B is going to still give you A. Please note this very well. It is called the absorption law. The 10th one, I have just 2 more to go. The simplification. simplification, and this says that A plus A bar dot B is the same thing as A plus B, just as A dot A bar plus B is the same thing as A dot B. A dot B, and that is a simplification law. The last one, and a very important one, very important one, is the one I call De Morgan's theorem. De Morgan's theorem. And De Morgan's theorem states that A plus B all bar is the same thing as A bar dot B bar. And then the other side of De Morgan's theorem, it says A multiplied by B all bar is the same thing as A bar plus B bar. That is De Morgan's theorem. De Morgan's theorem plays a very important role in Boolean algebra and in so many aspects of algebraic expressions and understanding real numbers. And one thing about De Morgan's theorem is this: when you break the bar, you change the sign. Break the bar and change the sign. You observe that the bar was covering A and B over here, including the operation, but when it was broken into separate for A and for B, the sign changed to multiplication. And the same thing happens here. When you have the big bar over all of them, when you break the bar, you have to change the sign in between them. De Morgan's theorem we'll be looking at. We'll be looking at De Morgan's theorem in subsequent videos. The proof of De Morgan's theorem we will see soon. Thank you for watching. God bless you.